Hi, this is Miss Park. Today we're going to graph parabolas in standard form and in factored form. Okay, so let's look at equations of quadratics in the two forms. So here I am, again, going to go into GeoGebra. All right, so you just, from any Google screen, just search up GeoGebra, go into it. And we don't need anything 3D because we're not going to do the 3D shapes in this unit. So we just go to the regular calculator. And it gives me this, this screen with the grid. All right, and up here on the left is where I can enter things. So I'm just going to zoom in on that for you so you can see it. And in here, I'm going to type just a regular, remember what we said about parabolas being called quadratics, and quadratic looks like a square. A quad means 4, it's got 4 sides, so it looks like a square. So that means in the equation of the quadratic, you will have x squared. So y equals x, and I'm going to make a little exponent. So I want to show you how to make the exponent. There's a little upside down v above the 6, so shift 6. It's called a caret. It's a little, I guess like a little hat. And so you press that and you see the cursor has gone to where the exponent would be. And I'm going to put a 2 here. All right, and so this is y equals x squared. So let me get out, and you can see y equals x squared is just a plain old parabola with the vertex at 0, 0, and it opens upward. And I can add things to y equals x squared. So for example, I can add some terms. I can go x squared minus 8x, right? Every time I do that, it's going to change the graph a little bit. And I can add a third term, make it a trinomial. So like that. Okay, so that would be graphing a parabola in what's called standard form. So standard form has all the terms listed from the squared, then just the x, and then just the number, just listed like that. There's no brackets or anything like that. Okay, so that's called standard form. The other thing we could do is we could factor this trinomial and graph the parabola in what's called factored form. All right, so I'm going to do that. How do we write x squared minus 8x minus 12 plus 12 in factored form? So let's go to here, a piece of paper. So we're going to start with x squared minus 8x plus 12, and this is in standard form. And then we're going to convert to factored form. So we need two numbers that multiply to 12 and add to negative 8. Okay, so find two numbers. Or if you want to do it with the area model, here's your area model. Okay, I have x squared here and I have a 12 here. So this will be an x and this will be an x. What do these two numbers have to be to add up to negative 8x? So we could try, well, 3 times 4 is 12, so, but it has to be negative. So let's go negative 3 and negative 4. And as always, you test these values. This will be negative 3x, this will be negative 4x. And when you add them up, you get this adds up to negative 7x and not negative 8x. So we know that that's not correct. So what else could we put in here? All right, so we're just trying all whatever combinations we need to try. And it turns out that here, I'm just trying to erase this. It's not working well. Okay. It turns out that if we go through what divides into 12, we can list the possibilities. So we have 1 and 12, 2 and 6, 3 and 4, and that's all. So we need a combination that adds up to negative 8. So that the 2 and 6 looks the most promising, but they have to add up to negative 8 and multiply to positive 12. To get to positive 12, either both numbers must be positive or both numbers could be negative. So this combination with negative 2 and negative 6 will add up to negative 8. So we know that to factor this is x minus 2 and x minus 6. Okay, and this is called factored form. So why do we care about factored form? What does it do for us? Okay, so here's what it does for us. How about if I go into GeoGebra and I type in the factored form of the equation and then see what we see? So I'm going to go back into GeoGebra and I'm going to type this in the next line. I'm going to type x minus 2 times x minus 6. What do I get? I get the exact same parabola, okay, as the first one. So let me delete the first one. Since we know they're the same, I'm just going to delete the first one so I just have one graph. So I'm going to click on it, 3 dots, delete, and the first one's gone. And now I just have the factored form one, which is exactly the same as it was before. So let's look at the 2 and the 6 in the equation and see, where do you see 2 and 6 here? Oops. Where's 2 and 6 important? All right, right there. 2 and 6 are the x-intercepts of the parabola. One here and one here. I wonder what happens if I click. Oh, it makes points. Okay, and it's calling them a root. So a root is another word for x-intercept. We also call it a 0, right? Because that's where the y is 0. So we have these two roots, and it's also showing us where our vertex is. Our vertex is the point 4, -4. And what do you notice about where the vertex is compared to where the roots are? Right? The axis of symmetry goes exactly halfway through the parabola. It cuts the parabola in half, and the vertex will sit on the axis of symmetry. So if you have a root at 2 and another root at 6, you know the axis of symmetry will be exactly halfway. So what number is halfway between 2 and 6? 4. So the vertex is going to be on 4 something, right? It's going to be on that axis of symmetry that's through 4. And so we know the vertex will sit somewhere on that vertical line. You know what I wanted to show you with vertex form, with factored form, is that, see how there's a 1 in front, right? There's no number in front of this. That's because I started with a simple trinomial that has only x squared. But what if there was a number in front, right? So let me put a number in front there. So I want to show you something cool with GeoGebra. Click on the tools here. Zoom in a bit. I want to play with some numbers in front of here, but I want to try different numbers, and I don't want to keep entering different numbers. So I'll click on tools and then select this thing that's called the slider. I'm going to select the slider, and it's giving me an instruction down below that says select position of the slider. So let me just put the slider somewhere out of the way down at the bottom of the graph. And the slider says, I'm going to let you play with values. I'm going to call them A. And I'll let you play with values, and we can let A go from -5 to 5. That works. And I'll say, okay. And now what it's done is it's made me a slider, this thing down here. I'm going to be able to slide this and change values of A. And then what I'm going to do, let me put it back to 1. What I'll do with the A is I'll put in my equation, I'll put an A in front, right? Right now, the value of the slider, the value of A, is 1. So we have the exact same parabola as before because I didn't change anything. I just multiplied the whole thing by 1. But what if I change A? So what if I take the slider and move it? So what if I make A 1.5? Notice what's happening. The parabola is getting narrower. And I keep making the A bigger. The parabola continues to get narrower and narrower. But what do you notice about those roots? The 2 and the 6, right? They haven't changed. So regardless of what I multiply the whole thing by, those roots are not going to change. All right, let's make A 5, right? So now the parabola is really, really skinny, but the roots are the same. So as long as the factors are x minus 2, x minus 6, those two roots, those x-intercepts, will still be 2 and 6. What if I move the slider the other way until it becomes negative? So watch my A getting smaller and smaller and smaller. My parabola is getting wider and wider and wider. And now here's 0. There's no parabola at all, so you see nothing. And now I'm going to make it negative. Oh, okay. So what happens when the A value is negative is the parabola opens downward, right? And I'm going to keep going, negative 0.6, negative 1, negative 2. Okay, so these are all, now they're getting narrower again. It's getting narrower again, but notice where the roots are. They're still 2 and 6, right? We're still 2 and 6. Regardless of the shape of the parabola, the roots are still 2 and 6. So as long as the factored form has x minus 2, x minus 6, those roots will be at 2 and 6. And that's the factored form. Let's go real quick back to my paper, because I want to now calculate, if I wanted to do a sketch of this without GeoGebra, How do I know what the parabola looks like? All right, so here's how we know. We're going to need some things. We need the x-intercepts, and we'll need to know how to get the vertex. So I'm just going to go back to my paper and share how to get the vertex. Okay, so I'm here, and I'm gonna do this. So I'm gonna write a parabola. So let's go y equals, and I'll just make this up. I'll go 3 x minus 1 and x minus 7. Actually, you know what? Let's have more fun. Let's go x plus 1 and x minus 7. So remember when we had y equals x minus 2, x minus 6, and the x-intercepts were 2 and 6? So it tells us that there needs to be a minus inside there. And so if we see a plus inside there, it means that the x-intercept was not 1, it's -1. So there needs to be a minus. So if you see a plus, it means that it's telling me that this is x minus -1. That's why it looks like a 1. So the x-intercepts are -1 and +7. So I can take those x-intercepts and put them on the graph, one at -1 and one at +7. Okay, so I got 2 points already on the parabola, -1 and +7. Now, where is my vertex going to be, right? My vertex is going to be exactly halfway between the two x-intercepts. So it's going to sit on the axis of symmetry. We saw the axis of symmetry divides the whole parabola in half. So how do you find the middle between -1 and 7? The middle number, in other words, the average of -1 and 7. So how do you find the middle? You add them up and divide by 2. That's how we find the average of two numbers. So -1 plus 7 is 6, divided by 2 is 3. So that means that at 3, we have this axis of symmetry. Let's pretend it went right through, okay? And that means that for the vertex is going to be 3 something. It's going to be somewhere on this axis of symmetry. So how do we figure out 3 what? First of all, is it going to be up on top here or down below here? Where is the vertex going to be? Right? Is it going to be up above or down below? So at this point, we look at the a value and we see the a is positive. And when a was positive, the parabola was opening upward. So that suggests that the vertex is down here somewhere, so that the parabola will open upward because it's got to go through these 2 points. Now, I know exactly where it goes. So now we will sub x equals 3 into the equation. So we have an equation. So if we put the x equals 3 into there, we can calculate the y that goes with 3. So this is 3 times 3 plus 1 times 3 minus 7. I'm substituting into here. Okay, and that gives me 3 times 4 times -4. And that looks like -48. So that tells me that my vertex is at the point 3, -48. So this is the point 3, -48. And now I can draw my parabola as a curve as best I can. All right, pretend this was nicer drawn. There you go. Okay, and this my parabola, okay, it's not the prettiest, but there it is. And then we label it with the equation y equals 3, x plus 1, x minus 7, next to the arrowhead. All right, and that's how we do it. So from the factored form, we take our 2 x-intercepts, we put them on the graph. We find our axis of symmetry that goes exactly halfway in between. We know the vertex will sit on that axis of symmetry, so we take that number that's halfway in between, and that is the x of our vertex. We take that x, put it into the equation. That gives us the y of our vertex. Put the vertex on, sketch is done. Okay, so hopefully this made some sense to you. Do you want to check this one, that the vertex is really 3, -48? I'll input this into GeoGebra real quick. Let's go y equals 3 times x minus x, was it x plus 1 times x minus 7. And it is this new purple one. Let me get out. It's this new purple one that it drew. And I can see if I go down below, zoom in for the purple one, I can click on this vertex and it tells me that's the point 3, -48. So extremum means it's either a maximum, the highest, or the minimum, the lowest. It means like the extreme value, the most high or the most low value. Okay, so 3, -48, so we did that correctly. Okay, so please practice and thanks for watching.